Hey, Natty Grace.
Hi.
How are you? Oh, I like your profile picture.
Thank you. It's from pictures from the middle school dance.
Oh, because that's not what it used to be.
No, it's not.
I feel like I don't remember what it used to be, but it
It was
was
a picture of me like dancing.
that's it. I wanted to say that, but and because Campbell's somebody else's is similar too. It has a ballet slipper too.
Mm-hmm.
Um,
Mine was from my first competition this year for my solo.
oh, okay. Because I was like, I remember, but yeah. It's you sweet people that come to math lab a lot that I know. I recognize the profile pictures. So, oh goodness, Finn, it's all good. You know her. Sorry about my dog barking.
Mine's probably gonna start barking soon in a minute. Apparently, someone's dropping something by our house today. So.
Oh, okay. They do that. It just scared me because he was laying in his bed right next to me, and I was like, oh, okay. I did this the other day with a couple of people who I was going over the review, and they were kind of like you and had a kind of a crunch for time. And they asked me to start from the back and work my way forward. But if there's a place in particular that you want me to start, since kind of have you need a focus, you've got a focused amount of time to get this done. So you just tell me what you want to do, okay, sweetheart?
Can I have some help with like exponents and factoring and finding the square roots?
Absolutely. Okay, so that's what we'll do. We're just going to start with the exponent ones and then work our way forward, okay?
Okay.
And I think, didn't I give you the second review too?
Yes, ma'am.
Okay. All right. So this is the first one. Do you want me to start with that one or go to the second?
Can you go to the second?
Yes, ma'am. I absolutely can. Hold on just one second. And I've been trying to experiment with, because remember, I think you've been here a couple times when the Cami software is actually locked up.
Mm-hmm.
And I'm trying to use a new program, but I'm not having a lot of success. Okay, you can load anytime for me and Natty Grace, anytime, because this has kind of been my problem. So I gotta try and get this fixed. I don't know why it does this. There you go. There's your doggy.
That's my dog.
I'm going to try something. I've never tried this before. I don't want to waste your time. I'm freaking out a little bit. Oh, here we go. All right. We'll just let the other one load. I need software to cooperate. Okay, here we go. All right, I'm just going to work straight through these. This one's easier, praise the Lord. Mm-hmm. On this one, what you're going to do, that 2 kind of stays just where it is since there's nothing else to be multiplied. The understood coefficients on the second 2 terms, the a to the 0 and the a to the negative 3, have an understood coefficient of 1 in the front. So basically your 2's just going to stay the same. And then we've got what you want to do with your exponents here. When it's multiplication, you're going to add. So I'm just going to abbreviate multiply. You add exponents. Okay. When it's division, you subtract. And when it's an exponent raised, when it's powers, maybe that's the best way to say that. When it's powers or exponents raised to exponents, then you multiply.
Okay.
So here, I don't know if that helps to kind of just break it down for you. Here we've got 2 plus 0 plus a negative 3. So that's going to end with 2 plus 0 is 0, and 2 plus 0 is 2, plus a negative 3 gives us a negative 1. And what that negative 1 does is take it to the denominator. So then we end with 2 over a. Because negative exponents take it down or to the denominator.
Okay.
Okay? Make sense?
Yes, ma'am.
Okay. And then this next one, we've got 3 times 2, which is 6. And then an understood 1 as an exponent with another understood 1 as an exponent. So that's going to be 1 plus 1, which gives us 2.
Okay.
All right. Now we're getting to some of the fun, more trickier ones.
Yikes.
Couple of ways of approaching this. You can do one of two things. And so I'm going to ask you what you think that you would do, and we'll work it that way. You can either take the exponent, just like I had set up here, that powers, you actually multiply. So you can actually distribute that 4 all the way across to every single one, or you can solve what's inside the parentheses first and then apply the power last. Which way would you do it?
I think I would probably apply the power last.
Okay. All right. That's probably what I would do too, except for when it's a fraction. Mm-hmm. Sometimes I have a tendency to apply that power first. But let's do exactly that. So we have a u to the 4th in the first term. We have no u in the second one, so we just basically will carry that forward. And then we have a u to the negative 3 in that final term. So 4 plus a negative 3 gives us a u to the first.
Got it.
All right, now on the next one is v to the negative 2. And in the second term, we've got a v to the second. So negative 2 plus 2, that gives us v to the 0, which is just simply 1. Mm-hmm. But we've got a 0. And then now we've got a 3 in that final term. So that's going to give us 0 plus 3, which gives us v to the 3rd. Okay? And now the only coefficient that we have throughout the whole thing, well, we've got an understood 1, but the only one that's not 1 is that 2. So we've got to write it down. So 2, because 2 times 1 is 2. So now this is what we should have ended with once solving everything inside the parentheses. So all of that then is raised to the 4th power, including the 2. So we've got 2 to the 4th, which is 16, because 2 times 2 is 4, and 4 times 2 is 8, and 8 times 2 is 16. And now we'll multiply that 4 times the 1. So that's going to be u to the 4th. And then we'll multiply the 4 times the 3, which is going to give us v to the 12th. So our final answer is 16, u to the 4th, v to the 12th, which is A.
Cool.
Okay. Does that help kind of break it down? These have just like things with the quadratic. They've got a lot of moving parts, so just take it one step at a time. You're really, really, really good about showing your work and taking it one step at a time, and that's really what's gonna make you excel in this part right here.
Got it.
Okay. All right, number 10.
I have a question about that one.
Yes, ma'am.
Since it's just to the 0 power, can you just exit out of the equation completely?
You're absolutely right. You can. Because anything raised to the 0 power is always going to be 1.
Okay.
So good question. Excellent observation. So yes, you can absolutely do that. So that leaves us with only working the 2 times x to the negative 1st times y to the 0. And once again,
you can x y out too, right?
Yes, ma'am. You certainly can. So really all that we're left with then is going to be that 2. And then we've got x to the negative 1. And what does a negative exponent do?
It goes to the bottom.
It goes to the bottom. So you end with 2 over x. So great observations on that one.
Yay.
You did great. All right, so the next one on number 11, we've got 4x squared over 3x to the 0. And just like all the others that you have quickly observed, that x to the 0 is just a 1. So all we're going to do then, you can do a couple of things also, just to make sure you're observing this, just in case. You also can subtract when it's a division, which I did write that up there. When it's division, you're subtracting. So you could, if you wanted to, do 2 minus 0, which is going to give you 2. And then you've actually put both the top and the bottom together at this point. But it's really going to do the exact same thing, no matter how you work it. Yeah. I don't know why she always cries every time I get on Math Lab. It's not thundering, is it? I have a greyhound that's afraid of thunder.
Oh, me too.
So, yeah, no doubt. Me too. It's going to be scary. So you got 4x squared over 3 is what you're going to end with. But no matter how you approach this one, whether you're approaching it 2 minus 0 and combining your 2 x's, or just thinking out of x raised to the 0 power as 1 and it cancels out, it doesn't really make much difference how you look at this one. You're still going to end up with 4x squared over 3.
Okay, cool.
Does that make sense?
Yes, ma'am.
Okay, cool. All right, on this next one, we've got an x in the numerator raised to the -3 power over x squared. So because it's a division, you're going to subtract. So I kind of want to write this one out for you, because you're going to take the exponents and subtract. And that's what that looks like. So you've got that x to the -3 over x squared. So that's -3 minus 2, which ends with -5. Does that make sense?
Yes, ma'am.
So now you've combined your x's. So you've got 4, and there's 4 is not divisible by anything in the denominator. So it would just stay the same. And there is no y in the denominator. So it's going to stay right where it is. But now we'll actually take that -5 on the x and put it in the new denominator, like that.
Okay.
Okay? Because it drives it to the bottom, since the end result was a negative number. Does that make sense? Okay, cool. Now, on number 13, this is one where I would probably apply that, work those parentheses first and then work out that whole, because you could think of the denominator as a grouping. You know how I kind of changed it from PEMDAS to GEMDAS this year, because we need to be thinking of larger groupings in the upper maths. So now I'm just going to rewrite this with this part being worked out. So we've got m to the -2, n to the 3rd, all over. And then you're going to distribute that 3, and 3 times 0 is 0. And 3 times 3 is 9, times 2 n to the -3. And now I'm going to combine that bottom row. So the next step will look like m to the -2, n to the 3rd, all over. And we've got m to the 0 times nothing with m over here. And like you've observed before, that's just a 1. So really all we have left then is a 1 there. And then we've got n raised to the 9th times an n to the -3. So 9 plus a -3 is 6. So we've got 1 times 2, which is 2, n to the 6th. And now the next step is to take m to the negative 2. So that's going to take it down to the bottom.
Got it.
And then you've got 3 minus 6. So it's going to look a little like that up there. So we're going to end with a negative 3. So that's going to stay on the bottom as well. So we've got nothing left on top except for the 1, the original coefficient. And then there's a 2 down here also. Does that make sense?
Yes, ma'am.
Okay, good. Good. All right, one more. Is this helping?
Yes, ma'am, it is.
Oh, good. Good. All right, on this one, I would kind of work with each individual grouping and then combine the top and the bottom, very last. So I'm going to distribute that 4 on the top, and 4 times negative 1 is x to the negative 4. Give myself some room. And then down here on the bottom, I have 2 times 1. I'm going to combine all of this. And then x squared, and there's no x squared in the second term, so I'm just going to rewrite it. And then I've got negative 1 plus 4, which is going to give me a y to the third. And now I'll combine the top and the bottom. So I have negative 4 minus 3, which gives me a negative 7. And then once again, I have nothing left on top except for my 1 coefficient. And then I've got 2. Did I do that right? No, I combined it with the 3. My apologies. I was like, I just noticed that's not correct.
You're good.
And then x to the 6th, y to the 3rd. Is that what you got too?
Yes, ma'am.
Good job.
Yay.
Yeah. I feel like the ones on the review, on the last review, were a little more sticky than these. But this is good review.
It is.
All right. Now, where do you want to hop to? You feel pretty good about
Can we do 15 real quick?
Absolutely. On this one, what I do first is I look to see what the highest degreed term is, to figure out where I need to start. And then I always rewrite them vertically. For me, that's just easier for me. So here, I've got an x to the 3rd in the first one minus 5x squared plus 3x, making sure that I keep my signs with my numbers. And then in the second one, I've actually got an x to the 4th. So I'm going to bring it closer out front. I have no x to the 3rd, so I'm just going to put a filler there. And then I've got a 6x squared. And then I've got a 4x, a negative 4x to be like making sure that I carry my sign with me. So 3 minus 4x is going to give me a negative x. Negative 5x squared plus 6x squared is going to give me a positive 6x squared. X to the 3rd plus 0 is x to the 3rd. And then you've got your x to the 4th. So it should be x to the 4th plus x to the 3rd plus x squared minus x.
Got it.
Good.
Okay.
Good. Now, key thing on number 16 is making sure that you distribute that negative all the way through. That's the only way it differentiates. Do you want me to work that one, or you feel pretty good about those?
I feel pretty good about these.
All right. Well, let's not waste any of your valuable time because I know. What time do you have to leave?
I have to leave at like 3:15.
Okay. And what you've got science tomorrow too, don't you?
Yes, ma'am.
All right. How do you feel about 19, like finding the products, multiplying these?
Foil?
Yes, ma'am.
I feel good about those. Adriana helped me in study hall on Monday.
Oh, that's good. Oh, I'm glad to hear that.
I like her.
I do too. She's really sweet. Really, really sweet. Very helpful. Smart girl. Very sweet. Just like you. All right. So where should we, are you feeling pretty good about when the
factoring I need help on.
Okay, it's the factoring.
28.
Okay. Whoop. Okay, here we go. All right. I feel like you're pretty sharp at looking at patterns. So I'm going to present this a couple of different ways and you tell me what you like best. Okay?
Okay.
All right. When they're simple like this, and when I say simple, what I'm referring to is when the coefficient, the leading coefficient is a 1. Like on 28, 29, 30, 31, 32. Those are all the leading coefficients are 1. Does that make sense?
Yes.
On the squared term. Then you can really just focus on that final term, that constant. Okay? Which in the case of number 28 is 32. So what you're going to do then is think of all of the factors of 32 that multiply together to give you 32, but when you add them or combine them, give you a negative 12. And what's really important on that is on that B term is to focus on the signs, actually on the B and the C term. So let's think about that. If it's positive, if it's a positive 32, the only thing I know that can give me a positive when I multiply it together and give me a negative when I combine them are two negatives. Yes. So I know right away that both of them are going to be negative. So that's going to eliminate B and C right away. Okay. I mean, when it's multiple guests, you kind of have the beauty of being able to eliminate things that don't make sense. But in this case, what are the factors that you can think of if you didn't have those options there that would multiply? Let's just look at the factors of 32. Let's see, there's 16 and 2, there's 32 and 1, there's 4 and 8. What else is there? Anything?
No.
I don't think there is. Okay, so what two of those, if you were to combine them together, would give you a negative, and obviously since it's positive, these are negative, all of these would have to be negative. So if I add negative 16 and negative 2, I'm going to have negative 18. Well, that doesn't work. If I add negative 32 and negative 1, that gives me a negative 33. So that certainly doesn't work. But if I add negative 4 and negative 8, it does give me a negative 12.
Got it.
Okay. So then the only thing I've got to choose from is D. Okay. All right. Let's do that same approach with number 29. On this one, however, we have a negative 70. So what that tells me is that one of my factors has to be positive and one of them has to be negative because a positive times a negative gives me a negative. Does that make sense?
Yes.
Okay. Now, the other thing I can learn is that the sign on the B term is negative. So that tells me my larger factor has to be the negative one. Because when I combine a negative and a positive number, you find the difference, and give the sign of the higher one. Okay? So for a negative 70, the factors are 10 and 7, 35 and 2, 5 and 14. I think that's it. Am I leaving any out? I'm not sure. So
that's it.
Okay, so I know that the larger one, actually, let me erase that. The larger one I said had to be negative. Okay? And the smaller one is positive. So what happens when I take a negative 10 and combine it with a positive 7?
Get negative 3.
So there I go. I've already done it. But just for the sake of walking through it, what happens when you combine a negative 35 and a positive 2? You get a negative 33. So that wouldn't work. Is this kind of making a little more sense? Or
Wouldn't
not
it
really?
be D?
A B?
D.
Oh, D. Oh, yes. I'm so sorry. Yes. Good catch. Yes, it would. So that's the other sad thing about multiple guess is if you look too quick, like Miss Sparks did just then, you could mark the wrong one, because see how close those are?
Yes.
So is this making a little more sense though?
Yes. Can we go to 33? Because I'm confused on that one particularly.
Okay. All right. So you feel good about the rest of those?
Yes, ma'am.
Praise the Lord. Good.
Woo.
I know. I love that. That just makes me feel so much better. Okay. Now, number 33. This is one of those what I call special ones, because remember how you said Adriana is the one that helped you, correct?
Yes, ma'am.
Okay. She probably went through FOIL. Is that correct?
She did.
Okay. All right. So when you FOIL, that B term is when you add the two, right? Because you have to combine them. You combine the outside and inside.
Yes.
And it becomes one term. Okay. That O and that I. All right. Now, when you have the difference of two squares, which that's what this is. So you've got a square at the front and a square at the back. And there's a subtraction sign in the middle. This is known as the difference of two squares, because it is, right? It's the subtraction of two perfect squares. So what that tells you is right away, there's a special factoring that goes on. What is the square root of n? N squared.
N.
What is the square root of 36?
6.
Okay, so what I'm going to tell you is that you've got n plus 6 and n minus 6 when it's the difference of two squares. And let me explain how that happens. If I FOIL this, I've got n squared, and then outside is negative 6n. Inside is positive 6n. And then last is the negative 36. What happens to those two middle terms?
They turn into 0.
Yes. So I have n squared minus 36. So this is a special factoring called the difference of two squares, because that middle term cancels out.
Oh, I remember now.
Yay! So if I had x squared minus 49, what would my two factoring binomials be?
X plus 7 and x minus 7.
Perfect. You've got it. You've got it. That's it. Exactly. And I want to tell you that's really, really good, because in Algebra 2, this is used a lot. And in trig identities, it will show back up too. and that's pre-calc. So
Yay.
it's a pattern that I'm just going to tell you, if you will start recognizing it now, it'll be a wonderful foundation for you.
Cool.
Okay. All right. Now on number 34, one of the main things that I want you guys to notice right off the bat is if you can get that greatest common factor. That's one of the first things I want you guys to start looking for. Particularly, I know you're moving straight on to Algebra 2. And the latter part, if I'm not mistaken, in geometry. Have you used the quadratic formula yet in geometry?
No.
Okay. You will do some factoring and use the quadratic formula. And have you used the midpoint and distance yet?
Yes.
Okay. A lot of this later on in geometry will kind of start showing up also, this particular algebra. So always look for that greatest common factor. So like on number 34, I know each one of those is divisible by 2 right away.
Mm-hmm.
Make sense?
Yes.
So you want to take that out first, which then it just gives you one of your more simple trinomials to factor, and you're good at those.
Yep.
Okay. And I feel like you're good at 36 and 37.
Can we go over 39?
Yes. And this is also the difference of 2 squares. Even though there's a coefficient on that front end, it's still a perfect square. Does that help you see it?
Yes.
So which one do you think it is?
D.
It is.
Yay.
Yes. And the same with number 40.
B.
It is.
Yay.
You're seeing it now. So, and then number 41 is just a perfect square.
Yes.
Because, so it's going to be 4x minus 5 squared. Do you see that? Or should we foil it?
Can we foil it?
Yes. What I like to do when I'm working through factoring ones is note if that first one is a perfect square, and it is, because 4x is the square root of that. And this one is a perfect square. So look at your A and your C terms and see if they're perfect squares. And in fact, they are. So I would then do this, except I didn't give myself much room. 4x times 4x is 16x squared. And then 4x, and then we'll do outside. 4x times 5 is 20x. And then we'll do inside. And then 5 times 5 is 25. Then we combine these, and that's 40x. So 16x squared plus 40x plus 25. So that gives me that right there. I think I worked it wrong, though, because I said minus. I did plus, and it's minus. My apologies. So sorry.
It's okay.
I hope that doesn't confuse you.
No, I'm good now.
Okay. That still would have been a positive.
I got 42, so can we go to 40?
Yay! One thing I want to tell you, there was a different one.
Uh-huh.
Lord Jesus, help me to think of what it was. On the review 1. And this was the difference of 2 squares, and I hated that it looked like this. Because if you actually did this, you could still factor a 2 out, but it still didn't give you the right answer. So it kind of bummed me out. Because you would have to factor a 2 out of both of them. And I don't know that everyone would know to do that. Does that make sense?
Yes.
And so then you would have 2 times 2, which would give you 4. So I don't think there's one on the final like that. And if there is, I'm going to give it to everybody. But on something like this, you would want to factor the common factor out first, which would give you this, and then do the difference of 2 squares.
Oh.
But
Okay.
that one's a tricky one. So I'm going to double check the final, and if there is one like that on there that's the difference of 2 squares with a GCF first, I will probably give everyone that answer. Because that one was a little trickier, and I'm not into tricking you guys. I do want to point it out to you though, because ACTs and SATs are into tricking you.
They are. I took the ACT last year and I was like, I know none of this.
Yeah. And it really, you probably knew more than what you realized. They just don't word them so that you're prompted by anything. It's kind of sad. So, but
I didn't get
you'll
the best
definitely get
grade.
better. I'm sorry?
I didn't get the best grade on it. So,
Well, the fact that you took it and you were in 7th grade, really, that's amazing in and of itself. So don't let that discourage you. Because what I try very, very hard to do, like in situations like that, like just now, I try to explain to you little things that will crop up in an exam like that or a standardized test like that, is that, the wording and the verbiage and even the problems that quote unquote look simple kind of have a trick inside them. So I always try to take the opportunity to point that out when I can. So anyway, all right. Now solve each equation by factoring. Pretty much this is factoring just like what we've been doing, except you're taking it one more step. Notice the difference between, say, number 38 and number 43. What is the difference when you look at them?
One had the answers are different.
Yes, and like what is different about the equations?
One is set equal to 0 and the other isn't.
Good job. So, and the instructions are different. One is just to factor, and the other is to solve by factoring. So that should tip you off when you've got that equals 0, you're going to do one more step. They've written one more thing in the expression or equation itself. So that should scream to you, Natty Grace, you're going to do one more thing after you factor. Okay? That's what that means. So, all of that being said, let me erase this. So I'm going to use all of this space up here. And what you're doing, once again, just to explain, just in case this comes up on an ACT, SAT, or any standardized test, when you're solving by factoring, and this is a quadratic expression or equation, that is the question that they're actually asking you when they say this is, where does this quadratic, when graphed, which becomes a parabola, where does it cross the x-axis? That's the question it's technically asking. So it's asking you for solutions, zeros, roots, x-intercepts. They're all exactly the same thing. Okay?
Right.
So what you're going to do here is factor it. And I can look at this and kind of tell that this is going to be a perfect square, because this is a perfect square and this is a perfect square. And the square root of 25 is 5. And when I double that, I get 10. So I don't know if you see that or not. Right away, is that a pattern you see yet?
No.
Okay. It's okay if you don't. So what you would do is kind of go back to our system of what two things multiply together to give you a positive 25 that when you add them, give you a positive 10.
Oh. I see
So
it
that,
now.
okay, so that's 5 and 5.
Mm-hmm.
So you would have x plus 5, and you could write it like this. You can write it any way you want to. I don't care.
Okay.
X plus 5 squared. Either way. If you want to write it out like that, that's fine. Fine with me. Um, but like I said, when it says solve each by factoring, once you've factored, I just kind of want you to know that's a note to you, Natty Grace, you're not done yet, because you have to take each one of those little factors and make
Mm-hmm.
them a little mini algebra problem now.
Uh-huh.
Okay. Okay. So,
Okay.
and these are back in the good old days. Remember x plus 5 equals 0? Don't you wish
Oh.
for those days sometimes?
Yes.
So you subtract 5 from both sides.
So you get -5, so the answer would be D.
Yep.
Yay.
So once you get to factoring, you're not quite done. You just go one more step and you take each one of those little factors that you got, the little binomials, and you set each one individually equal to 0 and you solve for that variable. That's
Okay.
the that's the difference when it says solve. And that's really the only difference. And after a while, your little genius self will probably start to look at the binomial and go, okay, I'm just going to pull out the opposite.
That's what I did for 44. Is it B?
Yes, it is.
Score.
Are you having some light bulb moments?
Yes.
I love light bulb moments.
Me too.
They're beautiful.
Yes.
I mean, because you're working these fast now. Really
Getting it
fast.
now.
I'm sorry?
I'm getting it now.
Yay. So how do you feel about 45 and 46?
Um, would it be A for 45?
It would be A. You're on fire.
And then 46. B?
It is B.
Score.
Yay!
Yay.
So are you feeling better about those then?
Yes, ma'am.
Oh, good. I'm so glad. All right. Moving on to square roots. And just to be sure, this was way back at the very beginning, and I probably should have asked this earlier. You do feel okay about substitution and elimination, right?
Yes, ma'am.
Okay. I was just I'm trying to make sure that I cover all of the major parts of the test. So, all right. So, taking square roots. The first thing that you want to do when you're solving an equation by taking square roots is making sure that the squared variable is on one side of the equation and the constant is on the other. But that's only for solving by taking square roots. Okay?
Okay.
So on this first one, in order to get the squared variable by itself on one side of the equal sign, I have to add 5 to both sides. So k squared minus 5 equals 95. I would add 5 to both sides, which would give me k squared equals 100. So now I've got the squared variable on one side and my constant on the other. And now I'm going to take the square root of both sides, and that's going to give me plus or minus 10.
Got it. And it's the same thing for 48.
Yes, this time you're going to subtract 7 from both sides. So it would give you 100. So A is the answer for 47. C is the answer for 48. And once on these, kind of like it doesn't, like obviously where was it? On number 43, there was only one solution, But typically when you're working with a quadratic, you're going to be getting two solutions because it's
plus and minus.
Yes, that's where that plus and minus comes in. And that's going to happen, you know, when you're completing the square, the quadratic equation, and also finding the square roots. That plus and minus is really important. And obviously, are you laughing at Guess because she's crying out in the rain? She's really okay because obviously she's on a screened-in porch, but she's just whiny. Can you hear my greyhound crying? Natty
no,
Gray?
I just hear a garbage truck from my house.
Oh. Oh, yeah. I don't think ours has come yet. Okay. Is this okay? So let's look at number 49 because it's a bit different. And 50. So
I got 50.
You did get 50? Okay, good. All right. But 49 on that one, let me erase this. On that one, to get that variable all by itself, you have to divide both sides by 36. So you'll have k squared equals 16 over 36. And so then the next thing that you're going to do when you take the square root is remember that the square root of a fraction is the same as taking the square root of 16 over the square root of 36. What is the square root of 16?
4.
And what is the square root of 36?
6.
So, and then that can be reduced one more time to this.
Okay.
So that answer is going to be D.
Got it.
There is a tendency for, I don't know why, and maybe this, you don't struggle with that. Sometimes, I don't know, there's a struggle to put the 16 underneath the 36, you know, what? Or whatever.
That doesn't make sense.
Yeah, it doesn't make sense to me, but I don't know. For whatever reason, as soon as there was a squared variable, I had that happen a lot on tests. I don't know why that threw some people for a loop, but it did. And then there was also a tendency to leave the 36 with the squared variable. I don't know. It was a little confusing. There were lots of unusual errors on that. So I just want to make sure that I'm explaining it well and you feel comfortable. Are you good?
Yes, ma'am.
Do we move on to find the value of C that completes the square, or do you feel good about this one?
Can we find the value of C?
Yes. So on all of these, what you're going to want to do is my little mantra of half it, square it, add it. Half it, square it, add it.
Got it.
So, and which one we're referring to is that B term. So half of 26 is
13.
And 13, so we've halved it. Now we're going to square it. What is 13 squared?
169.
Okay, and now it already shows it being added, but that's where that C is. But then you would add it. But the answer is B. So for number 52, half of 40 is
20.
And 20 squared is
400.
And so that C part shows it being added.
Got it.
Half of 42 is
21.
And 21 squared is
441.
Good job. These were all even. Half of negative 26 is
negative 13.
And negative 13 squared is
169.
Good job. Now, just to do one other thing to teach something of this concept, I want to go back to number 51 briefly. Well, I'm going to go back to each one. Remember when we halved number 51 and we halved that 26 and you told me it was 13, correct?
Yes.
Okay. What you have created is a perfect square that looks like that.
Oh.
Okay. That's what you've created by telling me half it, square it, add it.
Oh.
You have made a perfect square binomial. Because if I wrote out x squared plus 26x plus 169, if I asked you to factor that, you would tell me this.
Cool.
Okay, so let's do that to 52. If what you've done when you halved it, squared it, and added it is you created a perfect square, m plus 20 squared.
Cool.
Okay, so what is the perfect square binomial that you created for number 53?
A plus 21 squared.
Yep. So what did you create for 54?
P minus 13 squared.
You did. So that's what you're doing when you're completing the square. Okay? That's the whole purpose behind it. You want to create this perfect square because perfect squares are easier to factor and deal with. Okay?
Okay.
So I wanted you to see that before we move on to 55. All right?
Okay.
Now, so on number 55, we're going to complete the square much like what we've been doing, but we've got some extra numbers here. And those extra numbers kind of get in our way. So we're going to create space to complete the square. So for number 55, I have n, matter of fact, let me try something. You might want to pray. I think I opened it right over that other one. Would you mind reading me the problem?
No. It is, are you ready?
Yes, ma'am.
N to the second plus 20n minus 72 equals 10.
Okay. Okay. So the next thing that what we want to do, like I said, is we want to create space to complete that square. And this 72 is in my way. Okay? Because I really want to half it, square it to that one, to that B term. So what I'm going to do to create the space in order for me to do that is add 72 to both sides. Okay?
Okay.
And now I've created this space where I can make that perfect square. What is half of 20n or 20?
10.
And what is 10 squared?
100.
So I'm going to add 100 in this space that I created. Okay?
Okay.
And what perfect square binomial did I just create?
N plus 10 to the second equals.
And then I have to add 100 here. And I should have done that earlier at the same time because whatever you do to one side, you have to do to the other. Does that make sense? Okay. So now I've got that. And now I'm going to take the square root of both sides. And the first check that you want to do is you want to check to see if 182 is a perfect square. Do you know how to do that on your calculator?
Yes, ma'am.
Okay. And I don't think, I'm sorry?
It is not a perfect square.
I didn't think it was. So now we get the joy of factoring.
Yay.
Now, I'm a birthday cake person, but if you're a factor tree person, is that who you are?
Yes.
Okay. So 91, I believe it is.
Mm-hmm.
Okay. And then I don't know if it goes any further. Does it? The 91 is not divisible by 2. It's not divisible by 3. It's not divisible by 4. It's not divisible by 5. It's not divisible by 6.
It is divisible by 7.
But it's only 7 and 13, right?
Mm-hmm.
So really that doesn't do us any good because pairs make squares and there's not one single pair here. So that's not, there's no perfect squares in it in any way, shape, or form. And you kind of have to rule that out. So no perfect squares. So there's good news and bad news about that, Nettie Grace. This tells me that I have n plus 10 equals plus or minus the square root of 182. Okay?
Okay.
Because when I take the square root, I've still got that plus and minus, just like I've got a square root in all my other problems. Does that make sense?
Mm-hmm.
Okay. But the next step, I have to get n all by itself. So I'm going to subtract 10 from both sides. And now I have n by itself. And I've got negative 10 plus or minus the square root of 182. Which, if I'm not mistaken, they write it all the way out to be negative 10 plus the square root of 182 or negative 10 minus the square root of 182. Is that correct?
Yes.
What answer was that?
That was A.
Okay. There she is. Okay. All right. These take up a little bit more room, so it's easier to do on a blank PDF. All right, let's do the next one. I guess it's just going to leave me at that. Oh, yep. Not going to let me. Not going to let me open another one.
Oh.
Oh well. Here we go. I'm going to try to erase it without locking it up. It seems to be the erasers that make it lock up. So if you just pray. Let's walk through the next one together. Did this help a little?
It did. It helped a lot.
Oh, good. I'm glad. Did seeing, I kind of experimented and was praying. After we found the value of C that completed the square, me showing you the perfect square that you created, did that help a lot in understanding what you were doing?
Yes.
Okay. I think I may do that with on Math Lab later and hope it has the same effect. Hope. Okay. Would you mind reading me the problem again? I know it's a squared, but what's the second part?
Minus 12a.
Uh-huh.
Minus 7 equals 6.
Okay. Once again, I want to create that space to complete the square. So I'm going to add 7 to both sides. Now I've made that space. So what is half of negative 12?
Negative 6.
And negative 6 squared is?
36.
So I'm going to I've halved it, squared it, and I'm going to add it. And I'm going to add it to both sides because whatever you do to one side of the equation, you need to do to the other. And Natty Grace, you just made a perfect square.
Yay!
What is the perfect square that you made?
49.
Okay. Oh, that's over here. You're right. You did make one there. What did you make over here on this side? A minus what?
6.
Yes.
Yay.
There you go. All right. Does that make sense?
Yes, ma'am.
Okay. Because if you were to FOIL that, if you were to write it out and FOIL it, you would get this up here.
So it turns into a minus 6 equals 7?
It does, because you're going to take the square root of both sides, but it's plus or minus 7. Because negative 7 times negative 7 is also 49. So you have to think of all the possibilities. Does that make sense?
Yes.
Okay. So now to isolate A and get A all by herself, you're going to add 6 to both sides. So your two answers are positive 7 plus 6, which is 13, and then negative 7 plus 6, which is negative 1. So once again, with the quadratics, you kind of want to think in terms of getting two answers, because those are your zeros or your roots or where it crosses the x-axis. If you were to graph this parabola.
Got it.
Okay? All right. Moving right along. Do you feel pretty good about those?
Yes, ma'am.
Okay, good. It's nice when they come out even.
It is nice when they come out even.
Yeah, it's a beautiful thing. All right, so the quadratic formula, how are you feeling about that?
Can we do number 59? Because the no solution's kind of throwing me off for that one.
Okay, all right. So let's take it once again. I'm going to go back over here and start erasing and pray that Cammie doesn't lock up. And then would you mind, once it gets erased, reading the problem to me?
No, ma'am.
Okay, thank you. Are you feeling pretty good about the quadratic formula overall?
Yes, ma'am.
The key on that one, at least for me, is just making sure you watch your signs all the time. Because there's so many, moving parts to that beautiful quadratic formula. Okay, what is the problem?
2r to the second equals 9r minus 10.
Very first thing that you want to do with a quadratic equation when dealing with a quadratic formula is to get it in standard form before you do anything else. So in order to do that, I'm going to subtract 9r from both sides. And that's going to give me 2r squared minus 9r equals negative 10. And now I'm going to add 10 to both sides. So now I have 2r squared minus 9r plus 10. Okay?
Okay.
So now what I'm going to do, just to make sure I plug in everything right, is I'm going to identify my A, my B, and my C. So A is 2. B is negative 9. And C is a positive 10.
Okay.
So now I'll plug everything in to the quadratic formula. And there's our lovely plus or minus that we seem to have anytime we're dealing with the quadratics. She always shows up. So X equals, and then the opposite of B. What's the opposite of negative 9?
9.
Good job. Plus or minus. And then negative 9 squared minus 4 times a, which is 2, times a positive 10, all over 2 times 2, which is a. And now I'm just going to 9 plus or minus negative 9 squared is 81, minus 4 times 2 is 8, times 10 is 80, all over 4. That equals 9 plus or minus the square root of 1, all over 4. And now we have x equals 9 and the square root, well, my goodness, the square root of 1 is 1, all over 4. And now we have 9 plus 1 is 10 over 4, which reduces to 5 over 2. And we also have 9 minus 1, which is 8 over 4, which equals 2. So our two possible answers are 5 over 2 or 2. Is that on there?
Yes.
Oh, yeah, as 2.5. There we go. C. Would you like me to do another?
No, I think I'm good.
Okay. Any other questions?
Not that I can think of. Thank you
Nope.
for doing this with me.
Oh, you are most welcome, honey. Thank you for being so conscientious. I really appreciate it. That's amazing. And you're going to do absolutely great. Just take your time and you're going to rock this.
Got it.
Okay? Have a wonderful day.
You too.
Love you, sweet girl.
Bye.
Bye-bye.